On the map of Chicago, 1 centimeter represents 100 meters. We're going to come back to this statement, so I'm going to mark it here so we know what it says. Select all statements that express the same scale. Let's go over each of these statements. 5 centimeters on the map represents 50 meters in Chicago. So I'll start with the relationship I'm given. 1 centimeter, that's on the map, represents 100 meters. So I looked at this and thought, oh, okay, if I multiply both of these values by 5, so 1 times 5 gives me 5 centimeters, and then over here, I tried to do the same thing, and I tried to multiply by 5, but 100 times 5 is not 50 meters. And so I knew that this was not a relationship that represents the same scale. So I went to the next one. It says 1 millimeter on the map represents 10 meters in Chicago. So for this one, again, I started with 1 centimeter represents 100 meters. And the first thing I did was to change 1 centimeter into 10 millimeters. They're equivalent. And I kept the 100 meters the same. And I did this because I knew that I wanted to divide each of these by 10. So 10 divided by 10 gave me 1 millimeter. And 100 divided by 10 gave me 10 meters. And so I found an equivalent relationship, 1 millimeter on the map, representing 10 millimeters in the real world. For the next one, I again returned to the original relationship, but I reversed the order because I noticed that we had the in Chicago as the first item. So I thought it might be easier if I rewrote it, if I rewrote the initial relationships. So I'm going to say that 100 meters in the real world can be represented by 1 centimeter on the map. Now, I, from here, multiplied by 10. And of course, I'll do the same thing here. When I multiplied by 10, I had 1,000 meters. And over here, I had 10 centimeters. This is exactly what I was hoping would happen because I can replace the 100 meters with 1 kilometer. They're equivalent. And then I still have 10 centimeters. And so yes, 1 kilometer in the real world can be represented by 10 centimeters on the map. We have another true statement. I'm going to use that same relationship for the next one. So I'm going to start with the Chicago. This is the real world. It should be 100 meters, and that was represented by 1 centimeter on the map. Now I'm already getting worried about this because I have 100 centimeters in Chicago being represented by 1 meter on the map. So 100 centimeters in Chicago, that's the real world measurement, and that's not very big, and I'm representing it by 1 meter on the map. Like something's already feeling not good here. So I was thinking about replacing, say, the 100 meters with what would happen if I turn that into centimeters, right? So to turn this into centimeters, I would take the 100 meters times 100 again, because 1 meter gives me 100 centimeters, and that would be centimeters, and it would be equivalent to 1 centimeter on the map. There's no way. This doesn't make any sense. So 10,000 centimeters in Chicago is represented by 1 centimeter on the map. This just doesn't make any sense. So we're taking on 10,000 centimeters in the real world, and we're representing them on the map with 1 centimeter. This is a wrong answer. If you chose this as your answer, which is one of the two that you should not have chosen, and you did not choose either of the right answers, I think you got mixed up on a couple of different things. I think, first of all, you struggled perhaps with keeping things in the right order. I'm wondering if you set things up so that, like, I definitely did a better job on problems when, if a problem began with in Chicago, then I went back and I rewrote the numbers themselves so that I began with the information from in Chicago, even though in the problem, they start with the number from the scale versus the number from the real world. So I know that for me, I was more accurate when I made sure that regardless of how they gave it to me originally in the problem, that the particular specific sentence I was looking at was in the order when I wrote it mathematically of the problem itself. So that might be something that you look at when you are thinking about how to do a better job next time. I think that this was just a really confusing problem, and that maybe lining things up differently would have helped you be more successful if you try this kind of problem again.